Do you know what makes lightning flash across the sky? Or how a tiny bulb can light up your whole room? What about the TV you watch or the mobile phone you play games on? How do they actually work? The secret behind all of these is the same thing: electricity. It's an invisible power that flows all around us and makes our world come alive. Today, let's explore what electricity really is, how it's made, and why it's one of the coolest forces in the universe. Let's start from the very beginning. Everything around you, your chair, your phone, even you, is made of atoms. Inside each atom are tiny particles called electrons. Now, here's where it gets exciting. Electrons don't like to sit still. If we give them a little push, they start moving from one atom to another, kind of like passing a ball down a line of kids. This movement, this flow of electrons, is what we call electricity. But why does that matter? Because when electrons move, they carry energy with them. Think of a stadium full of people doing a Mexican wave. While doing Mexican wave in stadium, people themselves don't run across the stadium. But the wave of energy passes through the crowd instantly. That's what happens inside a wire. The electrons crawl slowly, but the burst of energy zips through at nearly the speed of light. That energy is what powers our world. It lights up a bulb by heating its filament until it glows. It spins the blades of a fan, turning electricity into motion. It charges your phone, lights the screen, and powers all its circuits so you can scroll, call, or play games. So electricity isn't just electrons moving. It's electrons acting like tiny delivery trucks, carrying bursts of energy to every device we depend on. Now, let us dive into the two main types of electricity. First up is static electricity. This happens when electrons gather in one spot and then jump out all at once. You know that feeling when you rub a balloon on your hair and it sticks, or when you touch a doorknob and get a little zap. It's like a surprise party for those electrons. Static electricity is all about that built-up charge, just waiting to break free. Another fun example: rub a balloon on your hair. The balloon steals some electrons, becoming negatively charged. Your hair, now positively charged, gets pulled toward the balloon, and the balloon sticks. And the most dramatic example of all, lightning. Storm clouds build up a massive imbalance of charge. When the difference becomes too big, nature fixes it with a giant discharge, a lightning bolt that can be hotter than the surface of the sun. Here's how it works. When two materials rub against each other, electrons can jump from one to the other. That makes one object negatively charged and the other positively charged. Then there is another electricity, current electricity. Static electricity is like energy stuck in one place. Current electricity is when electrons actually move, a steady flow of charge traveling through a path called a circuit. This is the kind of electricity that powers almost everything in your daily life: your lights, your fridge, your school's computers, and even your phone. But current electricity itself has two flavors: direct current DC and alternating current AC. Direct current flows in one direction only. Imagine water running through a garden hose. It goes forward, not back and forth. Where does DC come from? Batteries, solar cells, and fuel cells. That's why your TV remote, flashlight, or game controller needs batteries. They give a steady, one-way flow of electricity. DC is perfect for handheld devices which runs on battery because it's smooth and portable. Alternating current AC is different. Instead of flowing one way, it changes direction, back and forth, many times per second. AC is what comes out of your wall sockets. Power plants generate AC and send it through huge power lines because it's easier to move across long distances. Before it reaches your home, a transformer lowers the voltage so it's safe to use in your outlets. That's why plugging in your laptop or turning on your lamp works, thanks to alternating current AC. So static electricity is like a surprise spark, while current electricity is the steady superhighway of energy that powers our world every second. And here's something important. The electricity we actually use in daily life, in homes, schools, and cities, is not static. It's current electricity, and it comes in two forms: direct current DC and alternating current AC. Now you might be wondering, if current electricity is just electrons flowing through wires, how does it move so fast? Here's a cool fact. Electrons themselves move really slowly, slower than a snail. If we had to wait for each electron to travel from the power plant all the way to your lamp, you'd be sitting in the dark for ages. So why does your light turn on instantly when you flip the switch? The secret isn't the electrons themselves, but the electric field, the invisible push that zips through the wire at nearly the speed of light, carrying energy to your device right away. Imagine a long line of marbles inside a tube. Push one marble at the end, and instantly one pops out the other end. The marbles didn't race across the tube. The push traveled through them. That's what happens with electricity. The electrons are already there inside the wire. The electric field gives them a push, and the energy zooms along almost at the speed of light. That's why your lamp glows instantly. Okay, but how do we make electricity in the first place? Most of it comes from power plants. And here's the funny part. No matter how high-tech they are, coal, nuclear, geothermal, even some solar, most of them are just boiling water. Seriously. Power plants heat water into steam. The steam spins giant turbines, and those turbines spin magnets inside big coils of wire. That spinning motion sets electrons in motion, and that's how electricity is created. From there, the energy carried by those moving electrons travels through power lines and wires all the way to our homes, schools, and cities. In simple terms, the wires act like highways, delivering bursts of electron energy we call electricity straight to your sockets. So at the heart of our modern world, we're basically using giant, super fancy kettles to make steam. Of course, not all electricity comes from steam and turbines. We can also make it in other, clever ways. Solar panels capture sunlight and turn it directly into moving electrons. No boiling water needed. Wind turbines use the power of moving air to spin their giant blades, which then turn generators to produce electricity. Hydropower takes advantage of fast-moving water in rivers and dams. As the water rushes through, it spins turbines to generate electricity. So whether it's sunlight, air, or water, nature gives us many different ways to keep those electrons moving. Here's something most people don't realize. Electricity is not used up. The electrons don't disappear after powering a device. Instead, they go on a round trip called a circuit. The electrons leave the power source, travel through your lamp or phone, give their energy away, and then return to the source. Think of it like a roller coaster. The cars, the electrons, don't vanish after one ride. They just keep looping around, ready to carry energy again and again. That's why plugs have at least two prongs. One for electrons to go out, and one for them to come back. Electricity is the ultimate shapeshifter. It can become light in a bulb, sound in a speaker, motion in a fan, or heat in a toaster. It runs our homes, our schools, our hospitals, our trains, and even satellites in space. And here's the coolest part. Your body runs on electricity too. Tiny electrical signals travel through your nerves, telling your muscles what to do, helping your brain send messages, and even keeping your heart beating. So, what is electricity? It's the movement of electrons carrying bursts of energy guided by invisible fields flowing in circuits and powering everything from your phone to the International Space Station. It may be invisible, but it's unstoppable, the current that connects our world. And the next time you flip on a switch, remember, you're calling on one of nature's most powerful forces, electricity. Electricity isn't just science. It's magic science can explain. So stay curious, keep asking. Thanks for watching. If you enjoyed it, hit that like button and subscribe for more fun science stuff.